until now, when we put a process together, we have a sensitivity list. And that means whatever you list in that sensitivity list, anytime there's a transition on any of those signals, the process triggers, okay? But sometimes you want to trigger on other things. And so what VHDL gives you is the ability to attach an attribute to the signal, okay? So here is how these are accomplished. First of all, you attach them to your signal by listing the signal, and then you put a tick, okay? And then what you do is you put a keyword that is the attribute. So this is a table that shows kind of the supported attributes within the VHDL standard package, and they are keywords such as event, active, last active, last value, length, left, right, range. And so let's just look at like one or two of them that are very common and look at how they work. So the first thing that you always think about when you have a signal attribute is what is returned, okay? So in the first attribute we look at, which is event, so let's look at event, we are going to have a type of return Boolean. So you use this signal attribute whenever you would have a Boolean evaluation. So this would be like if this occurs, or case when this occurs, okay? So it's not like something you would make a signal assignment from. It's something you look at and then you make a decision based on that, or you take some action based on it, okay? So what this does is it is true when signal A changes, false otherwise. Now you might go, isn't that the same as just listing A in a sensitivity list? And it's like, it is the same as listing A in a sensitivity list in the fact that whenever A transitions, it will fire the process. But that's not the same when you used it in an if-then statement, okay? So if you said if A, well, all that would do is say you're only true when A is equal to a 1. But this one would say you are true whenever A changes. Does that make sense? Does that make sense? A little bit. So the difference would be I could say if, and then A tick event, and that it would only be true when A changes, okay? That is not the same thing as if A, and in that situation, this would only be true if A was a logical 1, okay? So it got you a little bit more information about the actual signal. Now, the other ones that are very handy are things like active. So it returns a Boolean. Let's use that again. You use a Boolean, and it's true when an assignment is made to A. So you can actually do something more sophisticated where you actually look at who's assigning to A. You know why that's important? Because if A was a 0 and somebody assigned a 0 to A, if you only look at the logic level, you would have never known that happened unless you had an attribute. So an attribute would say, I'm not even looking at if it's changed. It went from a 0 to a 0, but I tracked when somebody assigned to it. So you can use these when you try to set up sophisticated test benches to track who's assigning to what. Other ones, just to breeze through them, last event is returns time. So this is an attribute that will actually return time for something. And it's how long it's been since A last changed. Another one, time, last active, time when signal A was last assigned to. Okay, so you kind of get the gist of what these are. We have all sorts of these cool little attributes, but there's ones that are really important for making synthesizable logic, and these are them. The first one is tick event, and that's actually the only one, okay? Here is the way that you could model the rising edge sensitivity of a D flip-flop, okay? Remember, until now, all we've ever had is if we put clock in the sensitivity list, we are going to trigger anytime it transitions from a 0 to a 1 or a 1 to a 0, but we want to make an edge-sensitive flip-flop. Here is the agreed upon way to create a synthesizable model for a rising edge triggered flip-flop. The first thing you do is process, clock. It triggers every time clock transitions, 0 to 1 or 1 to 0. You say begin. In your Boolean condition you're going to check, you list clock tick event and clock equals 1. That means that clock tick event, you had a change on the clock, and in addition to that, the new value of it was a 1. Okay? The reason that this is important is because the community agreed that's what we're going to use, something very explicit to say, I want a rising edge triggered process that should synthesize into a D flip-flop. So it's very key that you use that syntax exactly. Even though you could get the same logic using other things, like just listing clock is equal to 1 would do it, but it wouldn't synthesize correctly. You always list clock tick event and clock equals 1. If you get that rising edge, what do you do in a D flip-flop? You assign D to Q and end the process. So this now, if you put this in VHDL and synthesize it, you would actually get a synthesized circuit that would be implemented in a D flip-flop. Okay, and that is a signal attribute.